Hello, and welcome to Lessons with Laurie, where we look at some of the big ideas and concepts taught in mathematics, kindergarten through grade 5. In the last lesson, I talked about the difference between the content standards and the process standards in the mathematics curriculum, and in particular, how they relate to the board games, which many of us are playing more frequently at home now. Board games such as Sorry or Monopoly or Yahtzee. All of those involve the process standards. Well, I also noticed besides board games, there's also been an increase in students playing video games because they're using their computers for that distance or remote learning, or they're using tablets or phones. And as they're doing that, I know that besides their lessons, they're also playing video games. Well, I know that it's not just students that like to play video games, because I've certainly walked down the aisle of many airplanes or been in coffee shops or in lunchrooms where I watch adults playing video games as well. And the question I might ask then is, what is the appeal? What keeps a 5-year-old, an 18-year-old, or myself playing those video games? Well, I think it's the just right principle. I call it the Goldilocks principle, that when I'm playing a video game, if I try one that's too easy for me, I quickly lose interest in it. But a good video game is designed so that there's just enough challenge so it keeps me coming back, keeps me working at something, helps me try to solve a problem. Oftentimes it has spatial reasoning involved in it as well. Well, I want to assure you that if your child is playing more video games, chances are that there's a high probability that there are some process standards that they could be focusing on during that video gaming time. And just to review what I meant by content and process standards, in mathematics we have our content standards, what it is that we are teaching in kindergarten through grade 12. Number and operation, data and statistics, measurement, algebraic reasoning, and geometry. That's the content, the concepts and skills that we're teaching. But overarching all of that are the process standards, how students are coming to learn the mathematics and apply the mathematics through connections, communication, representation, problem solving, and reasoning and proof. I would argue that as students are playing those video games, again, I think you're going to hear these process standards be referenced if you are engaging in those with your student. So I'd like to emulate what that might look like with some pieces that I have here called Pentomino Pieces, because spatial reasoning is critically important, and it's certainly a part of many of the video games that I have participated in myself and that I've also watched other people playing. So Pentomino pieces are made using 5 squares, exactly 5 squares. And when I put the 5 squares together, there are a couple of rules. They must touch along an entire edge. They can't come together at only just this vertex or halfway along the edge here. That when I place the tiles together, it must be along the entire edge. So one Pentomino piece might look like this. If I put 5 of them together in a fashion such as this, I get one long rectangle that is 1 unit by 5 units tall. That's a pentomino piece. If I take it and I rotate it to this horizontal position, it hasn't changed its shape or size, just its orientation. So this is still the same as that original one. So I'm going to move that back. If I take the red tiles now and I try to make a pentomino piece out of it, I can put 4 of them in a row, but the 5th one I have to put in a new location. I can't place it down here at the bottom because I would get the same pentomino piece as the green one. Well, if I move it to the side right here, I now have a shape that sort of looks like the letter L. If I take that 5th piece and I put it up here, I get the number 7. But the 7 and the L are exactly the same pentomino piece. The orientation has changed, but it's still the same. Likewise, if I put it over here, that's still the same pentomino piece. It's been reflected. So here are 2 of the possible pentomino pieces. Well, I might ask my child, how many pentomino pieces do you think are possible? Can you draw them? So give your child a piece of grid paper and ask them to trace along the outside to see how many pentomino pieces they could find. Well, I actually have a collection of pentomino pieces in front of me. You can find these online, meaning the template for them. I would not bother to go out and purchase them. You can make your own, print them as I have done on heavier cardstock, and then cut them out. Here's the pentomino piece that has 5 in a row. Here's the pentomino piece that has 4 in a row plus 1 more. There's that letter L, or the number 7. Here's the pentomino piece that has 4 in a row plus that 5th one placed in a new position. So these are different. How many total pentomino pieces are there? Well, again, if you look online, you will indeed find the template for them, and there are actually 12 different pentomino pieces. Sometimes they're referenced by their letter name, like this is the letter T right here. The one next to it is called the letter V, and you might look at it and say, well, it doesn't look like a V, Laurie. Well, if I take this and I rotate it a little bit, you can see how the letter V is made. Well, those 12 pentomino pieces, when you find them in a puzzle template, will probably be in a rectangular fashion that can be cut out. Because this is a rectangle that has dimensions 6 by 10 right here, 6 by 10, it means that once they're cut out, I should be able to take those pieces and rearrange them again back into the rectangle. Well, is there more than one way to do that? Well, in fact, there are quite a few different ways in which you can put the pentomino pieces back together to make that rectangle. So if you search online, you'll find the template on places such as Pinterest and other locations online like that. But you'll also find puzzles, and most of those puzzles have to do with spatial reasoning. And you might say, well, what's the big deal about spatial reasoning? Well, again, process standards over here. Spatial reasoning is really important in many professions that you and I are aware of. For instance, my dentist, when they're working on my teeth, they're looking at a mirror, they're looking at a reflection of my tooth. So I'm really glad that my dentist has good spatial skills. Certainly my hairdresser, as I've tried to cut my own hair, I'm seeing a reflection in the mirror of what my hair is, and as I'm trying to move my hands, it's not always clear which way I should be moving those scissors. Or the truck driver backing up, they're looking in their rear view mirror, they're seeing an image of what's behind them. There are many professions that involve spatial reasoning, certainly a landscape architect or a graphic designer, or anyone who's involved with any sort of packaging, whether it's in 3 dimensions, meaning they're packaging items that are going to go into a box that gets shipped to us, or into the grocery bag at the store. All of those are examples of how spatial reasoning is an important skill that we want to develop in all students. So when your children are playing those video games, I'd ask you to listen for and hear evidence that those video games do indeed involve these process standards over here. So thank you for watching. See you again next time.